right. Good morning, ladies and gentlemen. Here we go. Today we are looking at special cases. Today we're looking at special cases. We want to be able to solve equations, and sometimes, up until now, every equation that we've solved, we've had an answer for. Sometimes it's a real pretty answer, like a -7 or a +5, okay? Where we can get a number for x that balances the equation, a number for x that works, okay? But that's not always the case. Sometimes we have one solution, and that's what we've been learning right now. We've been dealing where we get a one answer. But it turns out that there's two more cases. Sometimes equations are not solvable. There is no answer. And sometimes the equation is always balanced. It's crazy. Whatever value for x works every single time. Okay, it's kind of interesting. So we're going to see how that looks, and then you get to practice a little bit today. So we have three different possibilities when we're solving equations. And up until now, everything we've done has been one solution, okay? But it turns out that there are two other special cases, no solution and infinite solutions, okay? And so let's look and see what happens here. Here we have one solution. We're going to go ahead and solve just like we've been solving. The nice thing is everything works just like it's been working all this time. Will you go ahead and start? What are you going to do on that first equation there? Distribute. Will you go ahead and distribute, please? All right, we're going to go ahead and distribute. So, distributing. Noah, what do you get when you distribute? 6x? Plus 27. Very good. 3 times 9 gives us that positive 27 equals -5 minus 2x. Going to rewrite everything. Now, that's all I needed to do there to clean that up, to simplify. Now, my rule from yesterday was letters to the left. What should I do next? Plus 2x. Very good. Letters to the left. We're going to move those letters, the variables, to the left-hand side. And to move it, we've got to do the opposite. So 2x plus 6x gives me 8x's plus 27 equals a -5. And then now x, all the letters, they just are lonely folk. They want to be all alone. So what are we going to get rid of? 27. So we're going to subtract the 27 to move it to the other side. Positive 27 and -27 disappear. We're left with 8x. This is a whole lot of negatives. How many negatives we got? -32. Very good. And then, again, this is 8 times x. How do we get rid of times by 8? Divide by 8. Okay, excellent. So that x is all alone. We get, good job, x equals -4. All right. So we got one solution for this problem. There's only one answer that we can plug back in and show balance. So if I take that -4 and plug it back in both places, our equation would be totally balanced. I guess I'll show you that so you can see what that looks like. So we can always check our answers. And again, I'm just going to take that -4 and plug it right back in to my left-hand side here. So 3 parentheses 2 parentheses in place of x, I'm plugging in my -4. And I have my plus 9 and my parentheses. So there's the left side. Do you see how that's the left side of the equation? And all I did was plug in the number in place of the x with parentheses. Always use parentheses. Okay. So that's the left-hand side. That left side equals 3. And if I use the right-hand side here, I have a -5 minus 2. And then instead of x, I'm plugging in my -4, my parentheses -4. So there's the right-hand side. All right, does the left-hand side balance with the right-hand side? Yes, it does. Okay, so we have balance. So So now we have two other possibilities that can happen today. Let's look here, the second problem. What do we need to do first? Distribute. Let's distribute. We got some 4 times that we got to distribute there. Let's see. If I distribute the 4, I'm going to get 4x, and then 4 times 3 is 12, and then we have the plus 1. I'm going to rewrite my left-hand side there. All right, and now that we distributed, what do we have to do next? Combine like terms. So we've got some like terms. We have that 7x and the negative 3x. What does that combine to be? 4, positive 4, good. The positives win by 4 there, and we have that minus 9. All right, and then what can we combine on the right-hand side? The 12 and the 1, very good. Those are just units. So 12 and 1 would give me 13. So I have 4x plus 13. Okay, cool. So we've cleaned it up, and now we can solve. And what was my rule? Letters to the left. So I want to take my letter on the right-hand side and move it. All right. So I'm going to subtract the 4x. Positive 4x and negative 4x make a 0. That goes away. And what happens over here on the left side? It also cancels out. Positive 4x and negative 4x cancels out. Well, that's interesting. And so I'm left with 9 is equal to 13. Does not negative 9 equal 13? No, it does not. It never does, and it never will because this is Earth. 9 does not equal 13. That is a false statement. That is false, and when we get a false statement, that means there is no solution, okay? Remember, everything in math is either true or it's false, which is what I love about math. You know, there's not really any gray area. It says right or wrong, okay? This is an absolutely false statement. Negative 9 does not anywhere on Earth equal 13, and so we say there's no solution. So you could use the word no solution, which I think is a better answer. You could use the symbol. This is the symbol. It is a circle with a slash through it. It means empty set. That is what it means, empty set. There is no solution set. There is no answer that can work, and that's what that means. It's empty, but I just prefer no solution. The reason I don't like the empty set symbol is, are there people who like cross your zeros? Like, there's people that write zeros with a slash through them. Do you see how that could be confusing? Yeah, I don't ever cross my zeros, but, you know, it does mean empty set, so you shouldn't cross your zeros. Anyway, all right, that's okay. So this can happen today, where your x's are going to cancel each other out. Be careful, all right? And we're just going to end up with a false statement, okay? Last thing that could happen is we could get infinite solutions. So let's go ahead and see what happens here on the third guy. What should we do first? Distribute. Okay, I'm going to take my negative 2 and distribute. Negative 2 times 3x is negative 6x. Negative 2 times negative 5. Positive 10. Very good. Equals 2x plus 10 minus 8x. Okay, then what do we need to do? Combine like terms. And the left looks just fine, but the right side, what do I need to combine? Yeah, my positive 2x and my negative 8x. Positive 2x and negative 8x, who wins? The negatives win by 6. So negative 6x plus 10 and negative 6x plus 10. Okay, so now we've cleaned it up, and my alliteration from yesterday is letters to the left. So letters to the left, we're going to take what's on the right. How do I move that thing? You would add 6x's to both sides. Negative 6x and positive 6x does what? 0, cancels out. And over on the left side, what happens? It also cancels out. Well, that's interesting. And I'm left with 10 is equal to 10. True or false? That is a very true statement. That is absolutely true. And in fact, is it true all the time? It's always true. Okay, so what this means is that there are infinite solutions I-N-F-I-N-I-T-E, infinite solutions. Infinite solutions. There are a million, billion, trillion different answers that would work. So I like just writing the word infinite, but there is a symbol for it. Have you seen the symbol for infinite? It's a sideways 8. I hate drawing it that way. I usually do 2 circles like that. But that's the symbol for infinite. It is a sideways cursive, or yeah, right. Yeah, let's rotate the paper and then do our 8. There we go. I don't know if that's any better. Anyway, so what this means when we have infinite solutions is that I can plug in any number I want for x. So let's see what happens here. I just want to test this theory. Give me a number for x. 24. Okay, let's try x equals 24. So here's what I'm going to do. I'm going to try x equals 24. I'm going to go back to my original equation here. And I want to plug it in and see if we get balance, okay? So here's what I'm going to do. -2 parentheses 3. Instead of x, I'm plugging in a 24. And then I have my -5 and my last set of parentheses there. So there's the left-hand side. Do you see what I did? You good? Okay, and I get -134 on the left. Let's see what happens when I plug it into the right. I got to plug in the same value. So 2 times 24 plus 10 minus 8 times that 24. So again, all I did was plug in 24 for the x's. There's your right-hand side. Hey, look at that. They match. And it turns out that any value for x. So again, I could go back up and I could do it again. And instead of 24, give me another number. 29. All right. So there's 164. I'm going to go back up and grab my previous equation, and I'm going to plug in 29 instead of 24. And again, hey, the left and the right side balance. Every single choice I choose for x will give me a balanced equation. It's kind of amazing, okay? And so that is the 3 things that happen. Every single solution for x will work, any number we want. Okay, which is kind of crazy. All right, ladies and gentlemen, let's go ahead and try a couple more just to make sure we are good with what happens here. Let's look at number 1. Solve each equation and tell us what we are getting here. What happens? What should we do first on number 1? Actually, you know what I'm going to do? Can I just say, hey, will you guys spend a few minutes and do 1, 2, 3, and 4 right now? Yeah? All right. Go ahead. Ladies and gentlemen, take a couple of minutes and do 1, 2, 3, and 4. How much time do you think you need? All right. So as you did 1 through 4, so the key, what you're answering today as you do your Delta Math, if you get an answer, if you're able to solve for your variable, then it's going to say, hey, then there is exactly one solution, and that solution is n equals -6. Or maybe they want infinite solutions or no solutions. So as you're reading through, be a little bit careful.